All right, back to the rational root theorem. Basically what this rule says is you can give yourself a number of options for what possible roots of your polynomial will be based on just your constant and your leading coefficient and the ratio of those two values. So if you have your constant term, which is -4, and your leading coefficient of 2, you can find the ratio of all of your p's and q's. So the factors of p's are plus or minus 1, 2, 3, 4, and the factors of q's are plus or minus 1 and plus or minus 2. So you need to find all of your p's divided by your q's. So you should have plus or minus 1 divided by plus or minus 1, right? Which would give you plus or minus 1. You have plus or minus 1 divided by plus or minus 2, right? Which would give you plus or minus 1/2. So I've already done that one. And then we have plus or minus 2 divided by plus or minus 1, which would give me plus or minus 2. And then I have plus or minus 2 divided by plus or minus 2, which would give me plus or minus 1 again. So I don't really need to write that again. And then we have our last group, which is plus or minus 4 divided by plus or minus 1. So I would get plus or minus 4, and then plus or minus 4 divided by plus or minus 2, which gives me plus or minus 2, which once again, I already have that written down. So then I don't need to have it twice. So here, within these options, so these 8 options, plus or minus, including the plus or minuses, all of my real roots will be one of these 8 options here. No matter what, one of my answers will be one of these 8 options, right? So if we were to practice that again, once again, you need to know your p's and q's. This next one's going to be a little bit harder because your p is -12. And then your q is going to be, here, I'll do my q's over here. Your q is going to be 3, which means your factors are plus or minus 1 for q and plus or minus 3 for q. For -12, you have a little bit more work to do, right? So -12, you have factors plus or minus 1, 2, 3, 4, 6, and 12. Right? And if we're looking at the ratio of p's divided by q's, right, I'm going to take all of my p's and I'm going to divide them by 1. And then I'm going to divide them by 3. So I'm going to have 1 plus or minus 1 plus or minus 1/3. I'm going to have 2 divided by 1 and 2 divided by 3. So plus or minus 2 plus or minus 2/3. I'm going to have 3 over 1 and then 3 divided by 3. So I'm going to get plus or minus 3, and then 3 divided by 3 is 1, which I already know, right? So I don't need to write that one down. 4 divided by 1, and then I have 4 divided by 3. So I have plus or minus 4, plus or minus 4/3. Got to continue with 6 divided by 1, which is plus or minus 6. And then 6 divided by 3, which is 2. I already have a 2 there, so I don't have to write it down. 12 divided by 1, which is 12. And then 12 divided by 3, which I already have written on my paper. So all of my real roots, the possibilities for my answers to this solving a polynomial, will fall within these options. So no matter what, the solutions will be one of these options, the real ones. So let's come back to what I said we would do later. So the irrational root theorem says that irrational roots come in complex conjugates, or in conjugates. So if you have an irrational root, so let's say 1 plus 3i is a root, then you also know that 1 minus 3i is a root. So the conjugates are always going to be a solution. You could also have something like 2 plus the square root of 3. That means that 2 minus the square root of 3 is also an option. Okay? So that might come into play as well later on in this chapter. All right, apologies for the long set of notes today. Hopefully cutting down the homework will help a little bit. Have a good day.